Let's do question number 36. Zumdahl 7th edition, page 616. The equation is acetic acid CH3COOH reacting with ethanol C2H5OH giving ethyl acetate CH3COO C2H5 plus water. I want you to notice that water is a product in this equation. So water must be included in the equilibrium expression. Water is not included in the expression only when the water is a solvent. So make a note of that. The K for this equation is given. K is 2.2. The question is, for the following mixtures, will the concentration of H2O increase, decrease or remain the same as equilibrium is established? And four sets of concentrations are given, A through D. So what you have to do is, you have to find Q. In each situation you have to find Q and compare the Q with K and decide which direction the reaction will shift. So if remember, if Q is greater than K, which means more products present means the reaction will shift to the opposite side, towards reactants. If Q is less than K, more reactants present, and the reaction will shift to the right, towards products. So if in first case, if Q is greater than K, more products present and reaction shift to the left, means the concentration of H2O will decrease. Second case, more reactants present, which means reaction moves to the right, which means H2O concentration will increase. So that's how, if Q is equal to K, the system is at equilibrium. So the H2O concentration will remain constant. So that's how you answer this question. So let's take A. Ethyl acetate concentration is given as 0.22 molar and H2O is given as 0.1. Acetic acid is given as 0.010 molar and ethanol is given as 0.010, same concentration, 010 molar. So 4 sets of concentrations. Find your Q. Q equals products over reactants, which is CH3COO C2H5 concentration times H2O over CH3COOH times C2H5OH, and plug in the numbers. It will be 0.22 times 0.10. There are no coefficients, so there's no exponents, over 0.010 squared, and Q is coming as 220. So you can see Q is greater than K, which means more products present and the reaction will shift to the left, which means H2O concentration will decrease. So that's part A. If you take part B, the Q will be 0.22 times 0.002 B H2O is 0.0020 over 0.0020, that's your acetic acid, and ethanol is 0.10. So that's your B. And when you solve this, you can see you get 2.2, which means Q is equal to K. So the system is at equilibrium, so H2O concentration will remain constant. So this is how you handle this question. I think D, C and D you can do yourself. C, Q is less than K. Q is less than K, which means more reactants present. So the reaction will shift to the right and water concentration will increase. D again, Q is equal to K. So you will work on C and D yourself. And let's do E. Part E. What must the concentration of water be for a mixture? The concentrations are given for other substances. So basically what you have to do is K equals 2.2 equals to write the equilibrium expression. I'll just plug in the numbers here. 2.0 times H2O concentration over 0.10 times 5.0, and so this equation, only one unknown, so your H2O concentration will be 0.55 molar. That's your E. F, section F. Why is water included in the equilibrium experiment? I already answered this question. Water is included because it's a product. If it is a solvent, you do not include the water. Right, I think we are done with question number 36.